Today we study the Calculus 1. The topic is limit at infinite limits. So now we will should care about this kind of question. The limit s tend to c fx I have known. Now how about x tend to positive infinity? At this time, how about the limit? And then x tends to negative infinity. How about this limit? And then together, x tends to infinity, including two cases. X tends to positive infinity and x tends to minus infinity. So now look at the definition. Limit as x tends to positive infinity. How to describe x tends to positive infinity? So now look at corresponding definition. Let f be defined on closed C to positive infinity. Open. How to express this? This means half closed and half open interval for some real number c. We will say like the limit fx equals capital L. X tends to positive infinity if for every integral less than 0, there is the corresponding number capital M. Try to understand. Integral is given and there exists the corresponding number capital M. This means different integral, different capital M. Such that we will have this x less than capital M, and we can get the absolute value of fx minus capital L, always less than integral. This means x is changeable, tends to positive infinity. Anyway, the absolute value means the distance of fx and capital L is as small as possible. So now, try to understand this expression. According to this idea, we will give another definition. The limit as x tends to minus infinity. How to express x tends to minus infinity? Look at this corresponding definition. Let f be defined on half open and half closed interval minus infinity to c for some real number c means any fixed real number c. We will select the limit fx equals capital L if x tends to minus infinity. For every integral less than 0, there is a corresponding number capital M, such that x less than capital M, x less than capital M means x tends to minus infinity. We can get the absolute value of fx minus capital L less than integral. Less than integral, what is our integral? For every integral, any small positive number, we always have this expression. This means the distance of fl and capital L as small as possible. As small as possible, at this time we have the limit idea, means the limit fx equals L. The two values as close as possible. So try to understand this expression. Together, according to the definition, x tends to positive infinity and x tends to minus infinity, we have this definition. Limit as x tends to infinity. This infinity means including positive infinity and minus infinity. So now look at definition. Let f be defined on the real number. Real number means minus infinity to positive infinity. We will select the limit fx equals L, means x tends to infinity, including two cases. If for every integral less than 0, there is the corresponding number capital M, such that if the absolute value of x larger than capital M, this means x tends to infinity, including positive infinity, including minus infinity. At this time, the absolute value of fx minus capital L is less than epsilon, means the distance of fx and capital L is as small as possible. Try to understand this expression. This means limit fx L tends to infinity, the limit exists. If and only if means equivalently, the limit x tends to positive infinity and minus infinity exist and they are equal. Now look at corresponding the geometrical meaning of the limit fx equals L. X tends to infinity. How to write it? Using our mathematical language. For any epsilon less than 0, epsilon means as small as possible some positive number. For every epsilon of it, there exists capital M less than 0. Do you remember the signs? There exists capital M less than 0. Epsilon is given, we can find some capital M. Giving another epsilon, we can find another capital M. And then, if the absolute value of x larger than capital M, we will have the absolute value of fx minus capital L less than epsilon. This means if and only if fx between the open interval, this means fx less than capital L plus epsilon and less than capital L minus epsilon. How to draw in the figure? Look at the following figure. In this means the pink curve is our function y equals fx. Giving the capital L, y equals L means some straight line y equals L. L plus epsilon, L minus epsilon, the two different blank lines, minus capital M, positive M, changeable. What changeable? Yes, x. This means x in the two open interval is changeable. At this time, all the values, the pink values, line in corresponding this interval, between this interval. So try to understand this figure. Look at another definition. The limit of a sequence. Let A means some sequence be defined for all natural numbers. At this time, the variable means the natural numbers n greater than or equal to some number c. We will select the limit n tends to positive infinity equals L. If for every epsilon less than 0, there is the corresponding natural number capital M. Why it's natural? Because n is an integral, so n less than some natural number capital M, such that the absolute value of an minus L less than epsilon. This means the distance of an and L is as small as possible. Try to understand the expression. Look at this definition. In finite limits, we will select the limit fx L tends to c. Pay attention to means c plus. How to express? L tends to c plus. At this time, the limit equals positive infinity. If for every positive number capital M, there exists the corresponding delta less than 0, such that x tends to c from the right hand. How to express? Yes, x is changeable in the right, another the open interval. X minus c larger than 0, less than delta. We will get fx larger than capital M. Capital M means every positive number capital M. Every number means fx corresponding is enough large. So the limit fx equals positive infinity. Try to understand this expression. According to the definition, do our examples. Example 1. Find the limit f over g. How to write it? Limit f and limit g doesn't exist. Why? Corresponding limit means infinity. So this expression means infinity over infinity. How to do? We can check. This expression, the high power equal 2. This expression, high power equals 3. We will do the following operations. Every term over x cubed. So equals limit f tend to infinity. The first term over x cubed equals 3 over x. The second, double x over x cubed equals 2 over x squared minus 1 over x cubed, corresponding expression. Now check this expression. At this time, we have some idea. Limit f plus g minus h. How to do? Get every limit. So we can get limit 0, 0, 0. 0 plus 0 minus 0 equals 0. Look at this. 1 minus 0 plus 0 equals 1. So 0 over 1 equals 0. Our limit equals 0. How to write it? We try to get some little summary. So note, if A0, B0 are giving some real numbers, they are non-zero. And m and n are non-negative integers. At this time, we will have the limit, have some summaries. Now look at the given condition, x tend to infinity. There are 3 cases. Case 1, n equals m. If the higher power they are equal, at this time equals a0 over 0, the limit. Another, case 2, n larger than m. N is larger than m. We will check. N is bigger, m is smaller. At this time, corresponding limit equals 0. Another, change the order of n and m means case 3. N less than m. At this time, the limit doesn't exist, equals infinity. The example 1 means in this question case 2. In this question, n equals 3, m equals 2. So means n larger than m. Finally, the result equals 0. Through the checking work, we found the result is correct. So now look at example 2. Find the limit x cubed minus double x plus 3 over expression times some functions. How to write it? We can check this. Yes, I tend to infinity. In this question, 3, 5. Together, 3 less than 5. We don't do anything, only according to the summary in the example 1, we can get the limit equals 0. On the other hand, you can check double plus cosine x minus 3 sin x corresponding the absolute value equals what? It's changeable, but anyway, it is a bounded function, less than or equal to 6. This means it is bounded. Less than or equal to 2 plus 1 plus 3 together equals 6. At this time, we can check. The limit expression equals 0. Another expression is bounded. 0 times some bounded expression together tend to 0. So together, this equals 0. Try to understand the idea. Some limit equals 0 times some expression. The expression is bounded. At this time, corresponding limit equals 0. Now look at example 3. prove the limit equals 0. This is a proof question. How to prove? Try to find our if and delta, our if and our capital M in the mathematical language. Look at the figure. Y equals sin x over x. In some mathematical software, we can draw in corresponding the figure if x tends to infinity, including two cases, positive infinity and minus infinity. At this time, the pink curve is as close as the x-axis, means tend to 0. How to prove? So now look at the mathematical language. For any if less than 0, in order to fx minus capital L absolute value less than if in this expression, what is our fx? What is our capital L? Yes, sin x over x is our fx. Capital L means our limit. In this question, special equals 0. Try to get this expression because minus 0 equals itself absolute value. Do you remember the sin x is bounded? So less than or equal to 1 over absolute value of x. In order to get this expression less than if from this we can get our absolute value of x. So now we can get, namely, absolute value of x less than 1 over if we have some idea about capital M. So let capital M equals 1 over if. If x absolute value less than capital M, we can get this expression go back itself, okay? Less than if. So we have this idea, sin x over x less than if, absolute value less than if. So we have the limit equals 0. Pay attention to our mathematical language. For every if less than 0, we can find means there exists capital M equals 1 over if. If absolute value x less than capital M, we can find it. At this time, fx less than L, absolute value less than if. We have the limit. So the limit is proved. Try to understand in the mathematical meaning how to find it, the capital M. So now look at example 4. Prove that limit n tends to infinity an equals capital L number 1. In this question is our an. The limit is 1 is our capital L. How to prove? In the similar meaning as in example 3, try to find capital M. So now look at the idea. For any if less than 0, we try to get an minus 1 absolute value equals, what is our an? Copy an. In this question, this is our an. Copy an, copy capital L. Minus 1 equals this expression. Yes, minus 1 bracket. The power is n minus 1. We don't care the values of n. Anyway, absolute value equals 1 over n. In order to an minus 1 absolute value less than if, we have 1 over n less than if. This means n less than 1 over if. Do you remember? Yes, we'll select natural number. So choose capital M equals taking integer function for 1 over if. If n less than capital M, at this time we will have an minus 1 absolute value less than if. Means the limit equals 1. Try to using the mathematical language. For any if less than 0, we can find capital M. Capital M is decided by if equals 1 over if, taking integer function, and then If n larger than capital M, we have the expression means the limit equals 1. Now look at example 5. Another proof question proves the limit sin 1 over x as tends to 0 doesn't exist. Pay attention to the key word doesn't exist. This means don't exist. How to prove? So now we'll look at this is the figure from some mathematical software. Y equals sin 1 over x. If I tend to 0, look at this figure. I tend to 0. Corresponding to values is changeable. Some special point equals positive 1. Some special point equals minus 1. What means limit? If the limit exists, means the limit is some fixed number, doesn't change. So now, the idea gives some the thinking process. That means taking some special points. What kind of points? X tends to 0. Taking xn equals 1 over n pi. 1 over n pi. Pay attention to. At this time, limit sin 1 over xn means limit sin n pi. We don't care the numbers of n. N equals 1, n equals 2, n equals any integer. Sin n pi always equals 0. Limit 0 equals 0. Okay? This means some special point equals 0. We can check the intersection points, the blue cross and the x-axis. Some special points equals 0. So now, if always equals 0, no. Taking another point, xn prime equals 1 over this expression, 4n plus 1 over 2 pi. At this time, corresponding the limit equals this expression. You can compute by yourself, okay? 4n over 2 means double n pi. According to our period function, at this time equals limit sin half pi. What means sin half pi? Every student knows the answer is 1, so equals limit 1. Limit 1, constant, equals itself, equals 1. At this time, there are two limits. One is 0, another is 1. The two limits are not the same. If the limit exists, means in every special point always have the same number. But in this question, the two limits are not the same. This means the limit doesn't exist. Pay attention to in your mind. xn prime, if n tends to infinity, always tends to 0, means our taking the point xn and xn prime only some special points in our given domain. The two limits are not the same, means limit doesn't exist. Try to understand the question. Look at our summary. Case 1. Limit fx, x tends to positive infinity equals capital L. If and only if in our mathematical language. For any if to less than 0, always find means there exists capital M less than 0, such that we will have x less than m, we can get the absolute value of fx minus capital L less than if to. Do you remember another? In the similar meaning, x tends to minus infinity. In the similar way, you can write it by yourself. Look at case 3. What is our difference? Yes, I tend to infinity, including case 1 and case 2, tend to positive infinity and tend to minus infinity. If and only if there exists capital M less than 0, such that pay attention to the absolute value y, including x less than m, x less than m, two sets, tend to positive and minus infinity. So we will use the absolute value of x. Look at the case 4. Limit n tend to infinity equals L. For any if to less than 0, there exists capital M less than 0 such that n tend to infinity means n less than capital M such that an minus L absolute value less than epsilon. Try to understand the four definitions, the four equivalent conditions, how to find our epsilon and capital M. So now look at the questions and answers. Question 1. Find the limit this expression. It is different. Why it is different? Limit. How about the expression? How about how many the terms? 1, 2, 3, 4 until the last double n minus 1. N tends to infinity means infinity terms. So we cannot write 0 plus 0. Anyway, the first not 0. It's constant. How to write it? The number of terms are infinity. We were using some mathematical idea. Write it. The first term, write it 1 minus 1 over 3. Pay attention to the factor half. Another half. 1 over 3 minus 1 over 5. Pay attention to, in the similar idea, the last term. 1 over the small number, double n minus 1, minus 1 over big number, double n plus 1. Pay attention to the corresponding multiplier, half. So pay attention. The first term and the last term. How about the middle terms? Why? You're so happy because minus positive together, 0. Minus positive together equals 0. So finally, equals half times bracket the first term and the last term. So now, original limit, how many terms? Infinity. So in the mathematical computation becomes only 2 terms. The question becomes very easy. Why 1 minus 0? 1 minus 0 equals 1. 1 times half equals half. So final answer is half. Now look at question 2. Try to find the limit. According to our idea how to compute I tend to 2. We can count off 2 cases. Case 1, I tend to 2 from the right side. Right side means I tend to 2 plus equals minus infinity. Why? Who can tell me why minus infinity? Because x plus 1, x tend to 2 corresponding equals 3 means positive. X tend to 2 from the right side means positive times some negative term. Together, positive, negative, together means minus. So the first means minus infinity. Case 2, in the similar way, x tends to 2 from the left side means tend to 2 minus corresponding this term, positive. X tend to 2 from the left side. X minus 2 means negative number. Similar meaning, x minus 3 minus. Pay attention to positive, negative, together positive. So we have positive infinity. We have the limit does not exist. So the limit doesn't exist. So now look at question 3. Prove that the limit f(x) in this question means an equals 0. How to prove? How to find capital M? For epsilon less than 0, there exists capital M equals 3 over epsilon. How about this signs? This means taking integer function such that if n less than capital M, we always have this expression. This means an minus L absolute value equals expression. This expression is less than 3n over n squared. This means this term becomes larger, equals 3 over n. Pay attention to this expression, and then we have 3 over n less than epsilon, we will have the limit an equals L. Try to understand this expression and the proof process. Now look at the final question. Try to prove the limit f(x) equals 1 if x tends to positive infinity. How to prove? If x less than 0, we always have f(x) minus capital L. How to get? Try to get the x less than what expression for epsilon. So we have f(x) minus L absolute value equals expression. How to do? Less than epsilon, we don't know. How about capital M? In that, this expression, less than 2 over x squared. At this time, for any epsilon less than 0, in order to f(x) minus L, absolute value less than epsilon, we will always have 2 over x squared less than epsilon. Step by step, we can get epsilon, getting x. This means x less than square root 2 over epsilon. Anyway, you will get some relationship between x and epsilon. Try to find it. At this time, let capital M equals square root 2 over epsilon. If x less than capital M, we always have this expression. You can check, go back the process. This means f(x) minus capital L, absolute value less than 2 over x squared. According to this expression, we know the value less than epsilon. This is our mathematical meaning. Means the limit f(x) equals 1 if I tend to positive infinity. So now class is over. See you next time.